Welcome to On the Shoulders of Giants. A good friend suggested that I construct this historical timeline just to show the evolution of thought, models, good science over many years by standing on the shoulders of giants. A few years ago, a discussion with a geologist friend, he mentioned that he had grown up in a household that was filled with books. He was surprised when I said I grew up in a household with no books whatsoever. The lack of books was not due to choice, it was due to poverty. I acknowledge the good fortune that has allowed me to work my way out of that poverty. In stark contrast to the first 20 years of my life, when there were no books, the last 64 years has been saturated with books, libraries from all over the world. Incredible privilege. Before we get started, I would like to make a few comments about how I have structured this timeline. You will notice that there are many pictures of books and people, and the structure for each reference, where possible, is headed with a picture. The name of the person, Paul Billingsley. The date, 1941, is not the date that I read this reference, this paper, but the date that it was published. So Paul Billingsley and Augustus Locke in 1941 noted the structure of ore deposits in the continental framework of the United States, that all large world-class ore deposits are proximal to deep faults. This format is followed throughout the timeline presentation. You may have noticed that the dates in the timeline have changed. They are now 1960 through 2006. The reason for this is that 2007 was a culmination of many years of research. That culmination has allowed me to put the word doctor in front of my name. The books and papers I have selected to present here, the few hundred I have selected, are the most significant influencers. A perfect example is Geochemical Self-Organization by Peter Ortoliva. This is a unique book that's a must-read for all geologists. Even though this presentation is aimed primarily at geologists, anyone with intellectual curiosity is quite welcome. Please do not hesitate to pause the presentation and read any of the comments I have made at the bottom of each reference. I believe the viewer by now will be aware that very few of the books and papers presented in these pages are geological in nature. I certainly read all of the requisite papers and books to obtain degrees in geology. However, it has become obvious to me through the construction of this timeline that most of the influential papers, books, have not been geological. Even though all four of these references are very important in respect to understanding mineral deposits and why they are where they are, comes through Coveney and Highfield in their book Frontiers of Complexity, where they show that distinguishing deterministic chaos from stochastic chaos is one of the principal hurdles that confront scientists working with potentially chaotic systems. Mineral deposits are chaotic systems. To have any idea of Earth processes, all four of these references are critical in respect to understanding. I especially recommend the book by Per Bak titled How Nature Works to all geologists. As a geologist involved in the most risky part of this business, that is, exploration, discovering new deposits, I especially recommend the book Against the Gods by Peter Bernstein. The excellent summary titled Mineral Deposit Modeling by Kirkham et al. 1993 is an excellent summary of creating mineral deposit models. I believe it's a must-read for all exploration geologists. Some very straightforward reasoning by Carlson, 1991, that metal deposits are clustered on many different scales. That is, its fractal distribution. Then some underlying geologic process must exist that also acts on many different scales. Shishel and Smales' paper 2001 in the book Deep Mantle Plumes and Ore Deposits, edited by Ernst et al., provides a review of the proposed relationships between mantle plume-driven magmatism and well-known ore districts. Peter Laznicka has been a contributor to understanding world-class deposits for many years. First and foremost, Laznicka's research has focused on rocks. And, as the author's research has shown, such a focus can lead to erroneous conclusions. Hugh Exton McKinstry was a Harvard University professor of economic geology and author of the textbook Mining Geology. His wife, Elizabeth, was a successful economic geologist in her own right. The McKinstries expressed the basic problem of focusing on rocks in a somewhat different way when they urged the study of areas away from the strong centers of mineralization in order to discover the subtle controls of ore. They reasoned that in locations of intense mineralization, even unfavorable rocks and structure contain ore. However, in the periphery, where ore forms only under favorable conditions, the controls are more obvious. The 1994 paper by Robert Grieve and Mosaitis, titled The Economic Potential of Terrestrial Impact Craters, was a vital game changer for the author. Clifford James was near the end of his professional career as a geologist when he noted the relatively poor performance of prediction in mineral exploration. Edward Lorenz in 1963, through his mathematical exploration into atmospheric dynamics, found that a purely deterministic set of differential equations describing Rayleigh-Benard convection could lead to vastly differing predictions of future weather patterns dependent solely on changes in the initial conditions. What Lorenz had discovered was deterministic chaos, which sounds like a contradiction in terms. Lorenz, in 1993, presented his findings in a book titled The Essence of Chaos. Armed with this information and that especially of Coveney and Highfield previously, the author came to realize that not only are mineral deposits chaotic, they are deterministic chaotic processes. Earlier in this presentation, the names Prigogine and Nicholas were mentioned in respect to research into complexity. Paul Manville, 1990, in his book Dissipative Structures and Weak Turbulence, shows how classical thermodynamics is inappropriate for researching complexity. Complexity is a much more profound problem and is linked to the roles of nonlinearities in far from equilibrium processes or systems. The formation of a metallic mineral deposit is a far from equilibrium process. The extraordinary book by Dieter Sornet titled Critical Phenomena in Natural Sciences, Chaos, Fractals, Self-Organization, and Disorder, Concepts and Tools is indeed an epic tome. Strange von Hee's calculations confirmed earlier presentation by Venek Mines, 1964, who through spherical harmonic analysis of the Earth's topography showed convincing evidence for at least 10 different scales of convection taking place in the mantle of the Earth. A book I recommend for every geologist is titled An Introduction to General Systems Thinking by Gerald M. Weinberg, 2001. Weinberg shows that model creation is a problem for all of science and most other disciplines as well. A review of the process of scientific modeling led to the powerful model building concepts and tools available through general systems theory and complexity. Professor Chongwen Yu, more so than any other researcher in the 1980s, attempted to combine the science of complexity, fractals, chaos theory, nonlinear dynamics, pattern formation far from equilibrium, and self-organized criticality with the formation of mineral deposits. Liu et al. Showed through their article, 1976, Small-Scale Mantle Convection System and Stress Field Under the Pacific Plate, that gravity data revealed a scale of convection through stress patterns in the lithosphere from mantle convection inferred from the low-degree harmonics. This data for Asia reveals repeating scales of convection at approximately 2,000 kilometer centers. In the mid-late 1990s, fractals became a subject of interest to geologists. This interest continued on into the early 2000s. The year 2007. A thesis submitted for the degree of Doctor of Philosophy titled The Spatial and Temporal Distribution of the Metal Mineralization in Eastern Australia and the Relationship of the Observed Patterns to Giant Ore Deposits. The introduced mineral deposit model, that is MDM, is the product of a transdisciplinary study based on complexity and general systems theory. Both investigate the abstract organization of phenomena independent of their substance, type, or spatial or temporal scale of existence. discontinuities in the mantle, Rayleigh-Bernard convection in the mantle, and the spatial distribution of giant mineral deposits are correlative. The post-2007 historical literature timeline. The long professional career of eminent geologist Warren B. Hamilton focused especially on the early Earth history. In the book Evolution of Archean Crust and Early Life, Kent Conti, in his chapter on How to Make a Continent, 35 Years of TTG, is our introduction to tonalite, trondhjemite, granodiorite, the oldest rocks on Earth. The book titled Varying Gravity by Craig, 2016, has its main focus on the interconnection of two unorthodox scientific ideas, the varying gravity hypothesis and the expanding Earth hypothesis. The 859-page book by Box and Draper, titled Response Surfaces, Mixtures, and Ridge Analysis, is a comprehensive introduction to building empirical models. Box's basic stance is that models are always wrong. The only thing that's important is the model useful? The research results of the dependence of convection planform on mode of heating by Gregory Hausmann, 1988, has proven to be especially useful in respect to the spatial temporal Earth pattern. Hausmann has discovered that when half of the heat is generated within the rocks and the other half is input through the base, the preferred planform consists of an array of hot axial plumes and elongated cold sheets. In the former case, the mean horizontal wavelength is about equal to the layer depth. For the latter, it is about twice the layer depth. Both of these references have been especially useful in understanding the origins of the spatial temporal Earth pattern. The book by Dentith and Mudge, titled Geophysics for the Mineral Exploration Geoscientist, is especially insightful in that geophysicists generally think in terms of patterns rather than in terms of rocks. Research by Ritsema et al., 1999, titled Complex Shear-Wave Velocity Structure Imaged Beneath Africa and Iceland, is instructive in that it shows that mantle plumes can extend clear to the core mantle boundary. De Bono, in his 1998 book titled Simplicity, presents a compelling case for the Newtonian approach to science. He maintains that discovering the underlying simplicity of a process is far more likely to be useful than a complex description of the phenomena. Impact Cratering, Processes and Products by Orzensky and Pierrazzo, 2012, shows that impact cratering is arguably the most ubiquitous geological process in the solar system, yet it has been ignored and continues to be ignored by geologists. Chapter 14, Plate Tectonics and Geology, 1965 to Today, by John F. Dewey, 2001, in Oreskes and Legrand's book titled Plate Tectonics, etc., etc. Quotes, from 1969 to about 1972, the impact of the geological ideas stemming from plate tectonics was muted by the characteristic geological aversion to bold, rational solutions to geological problems. Small-scale complexity commonly retards and obscures our understanding of large-scale simplicity. The presentations by Greg Corbett and Doon Wyborn have been especially useful in respect to developing our porphyry copper gold prospect in New South Wales using the spatial temporal earth pattern. Vicki Hansen, 2015, in her paper Impact Origin of Archean Cratons, seems to be the very first person to propose a possible connection between early Earth impacts and the creation of cratons. A more comprehensive comment will be made about Professor Stuart Ross Taylor at the end of this presentation. Simone Marche's 2014 paper on widespread mixing and burial of Earth's Hadean crust by asteroid impacts shows that the history of the Hadean Earth is poorly understood because few known rocks are older than 3.8 billion years old. It is recommended that the observer of this presentation go to our YouTube channel and watch the presentation When is a Craton Not a Craton? Robert C. Bostrom's book 2000 titled Tectonic Consequences of the Earth's Rotation is quite unique. Bostrom shows that the earth-tide forces acting on a convecting mantle would cause the convecting material to rotate in an anti-clockwise motion in the southern hemisphere and clockwise in the northern hemisphere. Earth-tide is the sub-meter motion of the Earth of about 12 hours or slightly longer caused by moon and sun gravitation. These forces induce cumulative vorticity in an imperfectly elastic mantle. These two books and article on oil, especially in the Middle East, are informative, however not geological. A geological model of the oil accumulations in the Middle East, especially Saudi Arabia, is presented on our YouTube channel titled Oil and Gas Fields, Arabia, Europe, Russia, Africa. Chuming Cheng has been at the forefront of using fractals, multifractals, and geomathematics as a means of predicting the most likely location of a world-class mineral deposit. Professor Chuming Cheng was one of the reviewers of my PhD thesis. Editors and authors within the Handbook of Mathematical Geosciences include both Chuming Cheng and Fritz Agderberg, both of whom were reviewers of my PhD thesis. Orszynski et al. In 2022 in their paper titled Impact Earth, a review of the terrestrial impact records, made the following statement, quote, "Over the past few decades, it has become increasingly clear that the impact of interplanetary bodies on other planetary bodies is one of the most ubiquitous and important geological processes in the solar system." The publications by Kirby and Swain, 2006, have been especially informative in respect to understanding mantle processes in Australia. This has been done through mapping the mechanical anisotropy of the lithosphere using two-dimensional wavelet coherence. The 2022 publication by Glickson and Yates titled Geophysics and Origin of the Deniliquin Multi-Ring Feature, Southeastern Australia, is independent confirmation of a prediction made by Robinson in 2007. The paper by David Mohl et al. 2014 has been especially useful in respect to understanding Archean komatiite volcanism, which is controlled by the evolution of early continents. Our results show that in the early Earth, relatively small crustal blocks analogous to modern microplates progressively amalgamated to form large continental masses and eventually the first cratons. Parfit, 2012, through multi-scale investigation of the African lithosphere using GeoCE gravity and gradiometric data, helps understand why diamond deposits are where they are. The book Plate Tectonics, An Insider's History of the Modern Theory of the Earth by Oreskes, editors Oreskes and Legrand, is by far the best summary of the plate tectonics model and its origin. Peter Lasnica, 1999, in his article Quantitative Relationships Among Giant Deposits of Metals, states categorically that it is not possible to predict the most likely location of a world-class, that is, giant ore deposit. However, there is considerable evidence presented in our YouTube channel showing that this is unlikely to be the case. Johns Glacier, 2001, makes an important point with respect to constructing simple physical models. Quote, major progress occurs by constructing simple physical models that describe the patterns that Earth scientists have selected out of the background noise. They have to exercise care with their observations because occasionally the background noise carries information that is critical to the process or processes under study. The research by Richard Tosdell and Dennis Cox et al. Have contributed to understanding the gold deposits, the gold metallurgy of Nevada. You can see the contribution made by these two groups on our YouTube channel in our presentation on the basin and range. The book by Andrew Glickson et al. 2018 titled Asteroids, Impacts, Crustal Evolution, and Related Mineral Systems with special reference to Australia has been useful in respect to understanding why giant ore deposits are where they are in Australia. Nobel laureate Richard Feynman produced lectures that have become classics. Not only did Feynman show intellectual curiosity, he also had a wonderful sense of humor. I recommend his autobiographical book titled Surely You're Joking, Mr. Feynman. The book, The Earth's Heterogeneous Mantle, edited by Deschamps and Kahn, makes many contributions in respect to understanding processes within the mantle. They state, of all methods available to Earth scientists, seismology has proved the most important because it affords the highest resolution. Accordingly, seismology has been the main source of information on mantle structure. For decades, radial seismic profiles have formed the basis for inferring structure and constitution of the Earth. The variations in seismic wave speed of the upper mantle and transition zone have been recognized as arising from phase transformations undergone by the silicate minerals that constitute the mantle as pressure and temperature increase. Pilkington et al. Show that geophysics, gravity, and magnetics are especially useful in respect to modeling meteor impacts. Savage and Sheehan, in their 2000 paper, titled Seismic Anisotropy and Mantle Flow from the Great Basin to the Great Plains, Western United States, has been used in a presentation on our YouTube channel. In our presentation, you will find as well work by Walker, 2004, on shear wave splitting beneath the Snake River plain, which indicates an upwelling beneath eastern Nevada. The title and the URL of our presentation is shown below. Nelson, Grand, Nash, and Smith all present interesting and useful information in respect to the Yellowstone hotspot. In the special issue on giant mineral deposits, Santosh and Groves make the following statement. Quote, "It is quite evident that it is not anomalous metal transport, nor unique depositional conditions, nor any single factor at the deposit scale that dictates whether a mineral deposit becomes a giant or not. A hierarchical approach thus is required to progressively examine controlling parameters at successively decreasing scales in the total mineral deposit system to understand the location of giant gold deposits in non-arc environments." Montine, 2011, in the article titled Magmatic Hydrothermal Origin of Nevada's Carlin-type Deposits, shows the five characteristics of Carlin-type gold deposits. Pearson, 2021, in his article Deep Continental Roots and Cratons, shows how diamonds are a useful tool in understanding the dynamics of the mantle. Our presentation on our YouTube channel, titled Diamonds Are a Geologist's Best Friend, shows much of the results of Pearson's work. The title and the URL of our presentation is shown in the bottom right-hand side of this slide. Moll et al. 2014, in their paper Archean Komatiite Volcanism Controlled by the Evolution of Early Continents, has revealed, quote, "Komatiites are rare, ultra-high temperature lavas that were erupted in large volumes billions of years ago, but only very few have been erupted since. They are the signature rock type of a hotter early Earth. However, the hottest, most extensive komatiites have a very restricted distribution, in particular linear belts within preserved Archean crust." The author has had a long-term relationship with Dan Wood. Dan was the exploration manager of Newcrest, a successful porphyry copper gold mining company in New South Wales, Australia. The author is in complete agreement with Dan when he says that, quote, "A new approach is required in how exploration is conducted and how these and emerging technologies are applied. Richard Shoddy, in the next slide, shows why this new approach is required. Richard Shoddy, in his publication titled The Outlook for the Australian Junior Sector in 2023, revealed that for every dollar spent on exploration worldwide, the return was 68 cents. Australia fared much better than the world on average, in that for every dollar spent in Australia, the return on investment was $1.20. The success of mineral exploration in Australia, rests on the broad shoulders of people like David Groves and Tim Johnson, both of whom are academics in Western Australia. By combining the book presented by Jonathan Kirby, Spectral Methods for the Estimation of the Effective Elastic Thickness of the Lithosphere, with the presentation by Karen Connors, that is, Crustal Architecture and Evolution of the North Australia Craton, has allowed the author to create a totally new model of the cratons of Australia. The development of that model can be seen in our presentation, A Geological Journey Across the Top of Australia. Following are the people and places within the timeline 1960 to 2024 with whom the author has had personal contact. All of these people are indeed giants with broad shoulders. It is only with hindsight that I acknowledge the privilege of working with Cox, Dole, and Dalrymple in the early 1960s. My position was titled Physical Science Aide. I worked primarily with Brent Dalrymple. Brent is a geochronologist, so he was determining the ages of the rocks that were collected by Alan Cox. In those days, you could not buy a mass spectrometer off the shelf, so Brent had to build in glass and a large magnet the mass spectrometer that went into the tar paper shack. The image over on the far left top is the tar paper shack, known as the tar paper shack, in which this scientific research took place. Alan Cox took thousands of orientated diamond drill hole core samples from around the world in various volcanic flows. The image here of Alan Cox with a hand diamond drill is in the Galapagos Islands. I recall a story from Alan Cox in respect to petrol. He was in Iceland, and at the time, the Icelanders were importing Soviet petrol. Alan said that the petrol is so full of sulfur that when he used it in his diamond drill, it destroyed the inside of the motor, because when petrol ignites with sulfur, it created sulfuric acid. Note the book The Age of the Earth by Brent Dalrymple. I will be making reference to this book later on in this presentation. Working for the Alaskan branch of the United States Geological Survey at the University of Alaska introduced me to many periglacial features, high latitude, high altitude geological features that most geologists never get to see. While working with Cox, Dole, and Dalrymple, I became aware of a presentation that was going to be given by Dr. Sidney Chapman. This series of lectures by Dr. Chapman were to be given at the Moffett Field NASA headquarters in Southern California near Silicon Valley. At that time, I had been accepted to attend the University of Alaska in Fairbanks to obtain a Master of Science degree in geology. Dr. Chapman's multiple presentations were primarily on upper atmosphere physics and the aurora borealis. About a year had passed, and I found myself standing to Dr. Sidney Chapman in the men's changing room at the university gym. I mentioned that I had attended his lectures in California, and he said, "Oh, we have a budding astrophysicist." I said, "No, geologist." He said, "What? What are you doing looking up? You should be looking down." When I said, "I'm interested in looking in every direction," he had a good laugh and patted me on the shoulder. It was 1967, and Professor Bill Compton was the person in charge of the mass spectrometer laboratory. There were many mass spectrometers in the lab, so there would be many students in the lab at the same time. So, because there was such great demand for the mass spectrometers, many students would work straight through their lunchtime. And there was hell to pay when Professor Compton found half-eaten sandwiches on the mass spectrometer shelves. The next day there was a huge sign in very large letters covering about 1/4 of the wall at the end of the laboratory that announced, "No eating in the mass spectrometer laboratory." Tony, who was the departmental practical joker, also was a frequenter of the mass spectrometer laboratory. Tony, on very short notice, had organized a very large table to be placed in the mass spectrometer laboratory, on which there was roast turkey and mashed potatoes and yams and carrots and all kinds of wonderful fresh food. And sitting at the table was a man in a tuxedo and a woman in an evening dress. And a waiter in appropriate attire was bent over taking the order from the man. And of course, in the background of this photo was that very large sign that said, "No eating in the mass spectrometer laboratory." The next day, a photograph, at least a meter on a side, showed up on the bulletin board of that wonderful meal being consumed in the mass spectrometer laboratory. It was 1967, and it took a while for me to become aware of the wholehearted competition between Professor Stuart Ross Taylor and Professor Alfred Edward Ringwood. Both had received moon rock samples contributed by NASA. Both aspired to be the first to publish papers on the chemical analyses of moon rocks. However, Professor Taylor was the fastest on the draw and won the competition at the OK Corral. It was 1967, and I was honored to be in the same department as Alfred Edward Ringwood, who was known in the department as Ted. Professor Ted Ringwood received many awards for his outstanding research into phase transformations in the deep mantle. I had arrived in the department immediately before the Christmas holidays, at which Ringwood was famous for throwing a Christmas party. I was invited to attend, however, it would be the last party of the next few years to which I was invited. I was sitting on the lounge as Professor Ringwood approached me and knelt down on one knee. He informed me that he had just returned from Japan. It was obvious that Professor Ringwood had consumed considerable seasonal libation. He informed me that the day that Miyashiro could do 21 one-arm push-ups, then Miyashiro would be his equal. It was a couple weeks later that Trevor came to my office and mentioned he was going to Professor Ringwood's party and asked me if I was attending. I said no, I hadn't been invited. I mentioned to Trevor Professor Ringwood's claim of 21 one-arm push-ups. Trevor didn't believe this claim, as I didn't, so Trevor said that he was going to bet Professor Ringwood a case of beer that he could not do 21 one-arm push-ups. The next day, Trevor came into my office and said, "Robinson, you owe me a case of beer." It was 1967, and visiting Professor Morris Ewing from the Lamont Geological Observatory was giving a talk. And since he was such a famous geophysicist, most geologists and geophysicists are well aware of his work. The attendance at that talk was standing room only. I got there early, so I was sitting in the second row. Professor Ewing commenced his speech with, "I use the E27-3 geophysical method for my research in Tierra del Fuego. Is there anyone here who is not familiar with that technique?" No one raised their hand, so I raised mine. Professor Ewing descended from the podium and the platform on which he stood and came down, leaned over the first row, and spoke to me in a quiet voice. He said, "Okay, let me explain to you what this technique is." It was 1969, and I found myself in far western Australia in the Jack Hills region. I was a subcontractor working for consultant Bill Johnson, who had his offices and all his employees in Perth. After I completed the Jack Hills job, Bill Johnson approached me to be a partner in his consulting firm, and I opened up a Sydney office of William Johnson and Associates. The Jack Hills were some of the most fascinating geology I had ever encountered. I recommend my presentation titled A Geological Journey Across the Top of Australia at our YouTube website. And it's 1979, with a job in the New Hebrides, which eventually became known as Vanuatu. New Hebrides was the only French-British condominium in the entire world. This led to some interesting conundrums. In the upper right-hand photo, the two traditional landowners were very friendly and led us through their property. They are standing in front of a Cracow breccia, which was filled with copper and gold. So even though the exploration program was a success, The deposit was not developed at that time due to political unrest. Within days of me returning to Sydney, Australia, there was what was called a bow and arrow revolution on in the New Hebrides. It became an independent nation and renamed itself Vanuatu. During this 1970 to 1995 25-year period, there were many people who passed through my life. However, these three people were outstanding during that period. Commencing with Greg Corbett over at the far right, his short course manual on Southwest Pacific Rim gold-copper systems was very useful in developing our Idleway prospect. In contrast to Greg Corbett was Dan Wood and Samuel Warren Carey. Both dismissed out of hand the possibility that there could be patterns around giant ore deposits that could lead to their discovery. A study of science, though, the history of science, shows that often, once a new paradigm is proposed, there is convergence towards that idea many years later. Sue Golding, Fritz Agderberg, Chuming Cheng have been responsible for acceptance of my approach to mineral exploration, recognizing patterns, and how those patterns relate to giant ore deposits. Sue Golding was my advisor at the University of Queensland, and Fritz Agderberg and Chuming Cheng were two reviewers of my PhD thesis. They are both geomathematicians and have been on the forefront of using fractals and multifractals in delineating giant ore deposits. I believe I may have set a record. I commenced a PhD scholarship in 1966 and was ultimately presented a PhD in 2007. John Mateen is a professor emeritus at the University of Nevada in Reno. It was through Professor Mateen that I became a member of the Society of Economic Geologists. He is especially knowledgeable in respect to the gold deposits of Nevada. Mateen notes, quote, "The characteristics of the Carlin-type deposits have been documented, but a widely acceptable explanation for their genesis is outstanding." I suggest that the viewer look at our YouTube channel at the presentation titled World-Class Gold Deposits in the Basin and Range, USA Update. On the right is an impact breccia located in central Nevada. On the left is us preparing for a day at one of our better prospects in southern Nevada. The research carried out at the University of Queensland, culminating in 2006, led to a real-world test of the spatial temporal patterns discovered during that research, and that resulted in what is the Idleway prospect in New South Wales, Australia. Here we have presented most of the people who have had a long-term relationship with us and the Idleway prospect. Commencing in the upper left-hand corner, son Sean Robinson, long-term field assistant. Next, Michael Banks, contractor consultant. Field assistant Jackie Robinson. Loving wife at Jacqueline's Gossan Hill. Russian geochemist Isai Goldberg. Cold and wet weather with field assistant Jackie Robinson. Lower left-hand corner, field assistant summertime with a pink Shawshank diorite in the background, which is exactly what you want to see at a porphyry copper gold deposit. Dune Wyborn at our prospect. Long-term investor and now general manager Nick Oppen. And finally, deceased Grigory Abramson. Comments are welcome, and you may enjoy seeing other presentations on our YouTube channel. The URL is shown below.